This was not an ordinary flood. High in the Himalayas, the disaster began with a powerful chain of events involving ice, rock, water, and steep mountain terrain. What happened next moved rapidly from the high mountains into the river system below, and for the communities downstream, there was very little time to react. At the source was a major collapse of ice and rock. Material came down the mountain with enormous force, generating a mass of debris that entered the river system. The important point is that this was not simply heavy rainfall filling a river. A mountain collapse changed the situation almost instantly, turning the river into part of the disaster. Once the debris reached the river, the danger moved downstream. Rock, sediment, ice, and water combined to create an extremely destructive flow. The river became the pathway carrying that energy toward communities below. This is what makes mountain disasters so dangerous. An event that begins high above can become a major threat many kilometers away in a very short time. The geography explains the scale of the event. The mountain valleys funnel water and debris into established river channels, allowing the surge to travel rapidly downstream. Instead of spreading harmlessly across open land, the flow was concentrated through the valley system. And along that route were roads, bridges, businesses, and communities. This raises one of the most important questions. Were people warned? Mountain rivers can change extremely quickly, and monitoring a river does not necessarily mean there is enough time to evacuate everyone downstream. When the source of the danger is a sudden collapse high in the mountains, the window between detection and impact can be extremely short. That difference between monitoring and meaningful warning can cost lives. But another question is just as important. Why were so many people exposed in the first place? Communities in mountain valleys depend on rivers for transport, trade, and access. Roads and bridges naturally follow these narrow corridors. Homes and businesses also develop close to the water because there is limited flat land. The same geography that makes these communities possible can also make them extremely vulnerable. When the flood and debris reached populated areas, the consequences were devastating. Homes, roads, and bridges were damaged or destroyed, while families were left searching for missing relatives and trying to understand what had happened. Rescue teams and local communities then faced another challenge: searching through debris in difficult terrain while infrastructure itself had been damaged. Behind every statistic is a person, a family, and a community. The scale of destruction is difficult to understand from numbers alone. Before and after imagery can make the change much easier to see. Roads disappear, bridges are damaged, river channels change, and areas that were once occupied can be covered by debris. But there is an important distinction here. Our reconstruction helps explain the geography. The underlying claims must be supported by verified satellite imagery, photographs, and reports from credible sources. The danger may not end when the first flood passes. Large amounts of rock, ice, and debris can block a river and create a temporary lake upstream. Water can then continue accumulating behind that natural barrier. If the barrier becomes unstable or fails, another sudden release could send a new surge downstream. That is why monitoring conditions after the initial disaster is so important. So what do we know so far? A powerful mountain event triggered a chain reaction involving debris, water, and the river system. Communities and infrastructure along the valley were exposed to the resulting surge, and the aftermath created additional risks. But important questions remain. Exactly how much material moved? How much water was involved? And how early could warning systems detect an event like this? Those answers matter, not only for understanding this disaster, but for preparing the communities that live downstream.